Hello, everyone. I'm your professor, Dr. Lisa English Dowdell, and welcome to Module 2, Introduction to Computers and Programming. Now, in this module, we're going to step back and we're going to look at the big picture. What computers actually are, how they work, and how programming allows them to do all the amazing things that we use them for. So let's get started. So I want you to think about your day. Maybe you checked your phone first thing in the morning. You paid a bill online, you might have watched a video, you might have sent a message. Computers are everywhere, from our phones and smart TVs to our cars and even refrigerators. They help us work, they help us communicate, help us play, and they help us learn. But what makes a device a computer? And how does it know what to do? The answer is programming. Now, a computer is a powerful machine, but it's not smart on its own. It only does what we tell it to do. And that's where programming comes in. Programming is the process of writing instructions that a computer can follow. And these instructions make up, what we call a program or software. So examples would include like Microsoft Word, like different video games, different apps, or even the software that runs a microwave. Now, every time you interact with a digital device, you're using software that was written by a programmer. Now, to understand computers, we need to distinguish between hardware and software. And a lot of this may be a review for you from previous courses. So hardware, remember, that's the physical equipment. These are things that we can touch, like the keyboard, the screen, the mouse, the hard drive. Software is the invisible instructions that tell the hardware what to do. So it includes applications like a web browser, or system software like Windows or Mac OS. Now, these two work together. So you got to think about it like this: hardware is the body, but software is the brain. A computer system, is made up of, and again, this is probably review for you. It's made up of a CPU or central processing unit, which is the computer's brain. Okay, it's made up of RAM or main memory, which holds temporary or data temporarily while, say, that program is running. And then it has secondary storage like your hard drive or your SSD, which holds like data more of a long term. It also includes input devices, like a mouse or a keyboard, and then it includes output devices like a monitor or a printer. And these components, they work together to receive data, to process it, and then deliver a result. Sound familiar? That's the IPO model that you're going to be practicing, I think, starting next week. Now, computers, they don't understand words or pictures the way that we do. You know, um, Everything like text or images or videos, it's stored as binary, which is a series of like zeros and ones. So one small unit of data is called a bit or a binary digit. And then 8 bits, they make up a byte. And then each byte represents a number or a letter or some other piece of information. So when you save a document or download a video, it's being encoded into binary that the computer knows how to process. Early programmers had to write in machine language, pure binary code. As you can imagine, that was very difficult. Now, over time, we've created higher level languages like Python, Java, C++ to make programming more human friendly. Now, these languages, they still get translated into binary, but they let us write code using real words or symbols or structure. Now, in this course, you're going to be writing pseudocode first. So I want you to think of it as a logic sketch. You'll write this before translating anything into code. You're going to hear us talk a lot about logic, and the course is programming logic. So why does logic matter? So, at its core, programming is about solving problems. You're telling the computer how to take input, make decisions, repeat steps, and then produce output. And that's why we start with logic, not syntax. If you can clearly describe a process step by step, then you can learn any programming language. So let's do a recap. Computers are made of hardware and they run software that's created through programming. Programming, what it does is it turns ideas into step by step instructions that a computer can follow. And to write effective programs, we need strong problem solving and logic skills. And that's what I'm hoping you'll take away from this entire course. Now, this week you'll read more about these components. You'll practice with maybe some a little bit of pseudocode, starting like next week, and then you'll create your own logic models using flowcharts as the course goes on. Now, don't forget to jump into the discussion board and share how programming helps make one of your everyday devices work. So that's it for this lecture. Now, last week in this lecture, we're kind of short and brief, just describing, like, on a high level, some of the topics for the module. As we start to proceed, like next week, as we start to really look at assignments and working through assignments, the lectures will become more tutorial. They'll be a little bit more lengthy. I'll walk you through as far as assignments and understanding the assignments, and any information that you might need to help you as we proceed, not just through the assignments, but as far as the modules. But for this week, what I want you to make sure that you do is to read chapter 1. Now, if you haven't gotten your textbook, please reach out to the bookstore and get your textbook. It's going to be very helpful, a helpful resource in addition to these lectures, moving forward. So you'll go ahead and you'll read chapter 1. That's going to help you with the quiz for this week. And then you're going to have a discussion post, like I said, where you're going to think of a device that you use every day, and you want to think about, like, how does programming actually make it work? And I want you to share your example. And then don't forget to respond to at least 2 of your peers' posts. Now, next week, we're going to be diving into IPO charts. Remember, that stands for input, processing, and output. And it's a simple but powerful way to organize how a program works. You're going to learn how to break down a problem by identifying, like, what data actually goes into it, what the program needs to do with it, and then what comes out the other side. Now, these IPO charts, they are one of the first tools that you'll use to start thinking like a programmer. And you'll even use them to, say, map out your final project ideas for our fictional organization, the Pawnee Community Center. So, get ready to really flex those logic muscles. Other than that, that's it for this week. If you have any questions or run into any issues, please reach out to me. Other than that, have a great week.